Okay. Perfect. Well, so welcome to everybody, and now we will start this very fast introduction to a programming language. So I assume none of you has ever written any line in any programming language. So I assume that you even do not know what a programming language is and what programming means. And I hope that at the end you will be all able in using Python. Python is very fast to use programming language, and so you will be able to solve simple problems, and you will be able also to apply some of the techniques, some easy part of the techniques you will talk about with Professor Damore about cryptography, about how to encrypt and decrypt messages. So, my name is Paolo Franciosa. I met some of you in Rome during a nice dinner, and I hope to meet you all in some next occasions. And we will meet once in 2 weeks. So, what I expect is that you will become familiar with programming during these weeks. So, obviously, these few hours are not enough for learning how to program, but I must say that it is a very nice activity. That is, writing programs is something that will be very exciting when you feel that you are able to solve problems. Well, so just obviously you can stop me whenever you like. You will probably stop me because I will be probably too fast, and there will be some details we need to fix in order to be able to go ahead with the course. So the first thing to do is that I hope you all are in front of a PC, and you all will be equipped with some software you need in order to program. So let's first talk about a bit about what the problem is. What is a problem? Actually, this is a very wide sense word, but when we talk about mathematics, or better, when we talk about computer science, a problem must be defined in some formal manner. For example, let's take one problem. The problem is solve a degree 2 equation. Okay, I think you all are able to solve a degree 2 equation. What does it mean to be able to solve a degree 2 equation? A degree 2 equation is something like ax squared plus bx plus c equal to 0. This is a degree 2 equation, yeah? So what do you mean by saying I am able to solve a degree 2 equation? Actually, I should take out this word here. I must say solve degree 2 equations. That's important. So the problem is not solving one degree 2 equation. The problem is solving any degree 2 equation. In the same way, if you say I am able to multiply two numbers, it means that whichever pair of numbers I give you, you are able to give me the product. Okay. So what is meant by solving this equation? Given what? What should I give you in order to ask you to solve an equation, a degree 2 equation?
A, B, and C.
Okay, so I mean, I give you A, B, and C, and you want to compute what? Which is the answer? I give you A, B, and C. By A, B, and C, I mean any triple of reals or real numbers. Okay, and which is the answer?
X.
X. Oh, well, let's try to be more precise.
The two solutions.
Two solutions is okay. What is a solution? What is? Is it a cat? A house? What is a solution?
It's a number.
It's a number. Okay, so the solution is two reals such that, okay, we know, such that if we take one of these two reals and I substitute the x by one of these two reals, I get that this is true, okay? To be more precise, or there is also another possible solution, that is the answer can be there are no real solutions. It depends upon which are the A, B, and C value. So we can say we solve a problem if for whichever triple we have, we are always able to answer in the proper manner. Well, so we want to go from triple, we want to go to a pair of integers, of reals, or no real solution. And what is this? If we assume that if we want to express all the possible input, I must say, okay, if I give you 3, 4, and 5, the answer will be, I don't know, whichever. Okay, if I give you 3.7 minus 7.1 and minus 1, then you answer in some other way, some number and some other number. Well, if I say that, if I would be able to write all the possible triples and say that for each triple we have a pair of numbers that are the solutions, we are computing a function. Do you know what is a function in the mathematical sense? What is a function? It's a set of pairs, or better, a function from a set A to a set B is a set of pairs A, B with A in A and B in B. So from all the possible pairs of one item here and one item here, there are some special pairs so that for this item, let's say A, the item B is the proper solution. Let's try to make a simple example. The problem is maximum among two numbers. Given what? Two numbers, x and y, reals. Compute a number, a real, that is the largest among x and y. Well, so, for example, if I give you two numbers, 4 and 7, the answer is obviously 7. Okay, what is this? This is a function from, you know this notation, R. Okay, obviously I just write R, but this is the set of reals. R squared is the set of pairs of reals, and the solution is a real, so is an element of this set, the set of real numbers. So from any pairs from any pair of reals, I can compute the proper real. Well, so since we will write something for solving a problem, the first step is defining what the problem is. Okay, so let's go back to this initial problem, computing a degree 2 equation solution. And now we come to another important definition. That is what an algorithm is. Actually, algorithm has a very bad, it seems to be a very bad word now, because an algorithm is something that decides for our life, and actually an algorithm is something that is very, very ancient and very easy to define. What is an algorithm? Does anybody of you know what an algorithm is?
A set of rules.
A set of?
Rules.
Sorry? Oh,
Rules?
not exactly a set of rules. What's interesting is the origin of this word is from algorithm, because that probably is not written the proper way. Algorithm was a mathematic from Persia, and we all owe to this guy the first algorithms that have been written. What he wrote is describes a process to make arithmetic operations. So when we are trying to multiply two numbers, and we write the first number, then the second numbers in some column way, and we start multiplying one digit by one digit and make sums and so on, you are applying a process that has been described by this guy here. So what an algorithm is a description of a procedure to solve a problem. And by solving a problem, I mean any possible input. I want to have the proper output. And so we all know which is an algorithm for solving a degree 2 equation. What do we do for solving a degree 2 equation? We are given A, B, C. What do we do first?
We calculate the discriminant.
Yes, you compute the discriminant. So we compute delta as, okay, what is delta? You know, it's a b squared minus 4ac, is it? Then, what do we do now?
We do minus b.
Yeah, no. First, you have to check something else, because if you say minus b plus, yes, you cannot compute. You write to write square root of delta, something like this. But you know that you cannot even try to do this in some cases.
You have to check if it is greater than 0.
Okay, so there is a sequence of steps. So some of you say the set of rules. More than rules, I would like to say steps. The steps are, first, compute delta as this. Then, wait a moment for this and say second, check whether is larger or equal than 0. And if not, stop, no solutions. If yes, okay, if yes, we say, so our output is this expression here divided by what?
2a.
2a. Oh, that's a problem also. Because the other, we say either this or this, is it? So we say the output is either what we, no, it's both, minus square root of delta or plus square root of delta. Okay, but I mean, I see another problem here.
A has to be different from 0.
Yes, I say given any triple reals, and we cannot do this. We cannot divide by 2a if a is 0. So first of all, before computing delta as this, let's say step 0, check a is not 0. Why? What can we do if a is 0? What happens if a is 0?
You solve the first degree equation.
It's a degree 1 equation, so we can compute a solution, but it's different. We apply a different step. So we can say if a is 0, solution is, which is the solution of that equation? Okay, we know it should be something like minus c divided by b. Is it? Actually, we should also check whether b is 0. But so it can be a bit more complex than it seems. Otherwise, go ahead with step 1. Is it okay? Here we go, here and here. Yes, writing a process to solve a problem is much more difficult than solving a problem. If I say multiply two numbers, you are able to do this on paper. If I say you write which is the process you apply to multiply two numbers, it's much more difficult. And we are dealing with writing algorithms. Well, one further step, what is a program? So an algorithm is the description of a procedure to solve a problem. A program is an algorithm that can be performed by a computer. This is an algorithm, sorry, it's wrong here. This is a good algorithm if we are able to read in English and understand what it's meant here. The problem is that now we want that our process, our procedure must be executed by a computer. So we cannot write it in English, even if we all are looking at what can be done by artificial intelligence, but we will not talk about it. In order to make a procedure, this process, be executed by a computer, we need this to be written in some special language. And it's what we call a programming language. So we will write a program that solves some problem when we know an algorithm and write it in some programming language. What is a programming language? A programming language is a language. So it's a language. It's a way to express concepts like a language, like Italian, English. It's a special language that can be, in some sense, understood by a computer. Well, and there are hundreds of different programming languages. So we don't have time to talk a bit more about programming, but we are lucky because we can use programming languages that are very close to our way of expressing procedures. For example, just to give you a couple of examples, and there was once upon a time there was a programming language called COBOL. COBOL was a programming language in the late 60s years. That is, COBOL means Common Business Oriented Language. And it was maybe the first attempt to describe an algorithm in a language that is not too hard for humans. And they tried to write something that was clear, a bit close to English. So if I want to say this in COBOL, I say, and I had to write something like what I'm writing here: compute delta as B star B minus 4 star A star C. Something like this. If I want to say it in Fortran, that is another language, still in late 60s, and the name of this language comes from formula translator, Fortran. I write this in a much compact way, and I write this like delta equal to B squared, B star B minus 4 star A star C. That is not so different from what you can imagine. Well, why can we write, and then you say if delta larger than 0, and so on and so on. So it's easy to understand what it means, especially for simple problems. And we can describe this process. We can describe this process in this way, and a computer can read this way of describing a process and execute all these steps, because we have some software, some program that is able to understand this language and make the internal circuits of the computer perform these steps. Well, so what we need is some tool for programming and executing these programs. Well, and we will talk about a bit more modern language. It is called Python, or better, Python 3. Don't forget this 3. We will use Python 3 because Python 3 is different from Python 2. It's really different. It's one of the rare cases in which a new version of something that is related to a computer, a new version is not compatible with the old version. Usually, when you have what can I say, Acrobat Reader version 7 makes what is done by Acrobat Reader version 6 plus something else. This is not the case with Python. This language uses some ways of writing these statements that is not the same as in Python 3. So if you're using this language, you must write the same things in some different manner. Okay, so let's come to a software that is called Tony. This is a software, Tony, And I really ask you to do this. So you go to the web and you look for Tony. Actually, Tony means a lot of things. So write Tony Python, it's better. And you go to this Python IDE for beginners. It's a very easy to use tool, very light. It's not a professional tool. It's free, and you can use this on Windows, on a Mac. You can also use it on the web. You can use it on your smartphone also. And if you go to this website, you find a download button. You can download this version of Tony for your PC. And when you try to do this, you will be asked to download the best you can do is download the portable version. Okay, so you will install this. I already have installed this, and this is what we get when we are running Tony. What is Tony? Now I will use this. I will use this window here as a blackboard. Tony allows us to write programs, and we all know what is a program. So an algorithm in Python 3 language, and ask the computer to execute our programs. And Tony is called an IDE, that means integrated desktop environment. So it's an environment to write programs and execute programs. Well, you will see these windows here. And this lower one is a place where we can write here our Python statements. And they are executed on the fly. So you just write a statement and this is executed. So it would be very nice if you, in this, while I'm talking to you, you also try to download Tony. It's very light, and install Tony on your PC. So I will be very slow now. I really do like if you do this just now. You are on it. You are connected to the internet, so you can go. You can go to this website. Where is it? I closed it. Okay, don't worry. You can go to that website and to the Tony website and download and install this object. What's included here? This contains a software that translates Python statements. By statement, I mean a step, an instruction, what we ask the computer to do, into the computer, let's say internal language. You can imagine that our computer can understand statements written in some very hard to understand language, something that is like this. You can say this, for example, means sum two numbers. Instead of writing this, we will write something like A equal B plus C. And this will be translated into some internal, we call it machine language. and we don't want to know this language, but we want to know this language here. So we will learn the Python language, and this object here, Tony, will translate all we write into the machine equivalent language. So we can forget about this, and we can only use our very easy to write Python language. And all this is included into Tony. Okay, so I hope you, in the meanwhile, you are downloading and installing Tony, and you can run Tony. And I start writing here an instruction. What can we do here? We can write expressions. Okay, we will go back to the primary school very, very often. Expression like numbers, like numbers with operators, and something like that. Arithmetic operators, we will use, first of all, integer numbers, for example, 56, for example, -4, for example, 0. And we will use float. That means, let's say, real numbers. For example, 3.14, and you know what it is. For example, 0.00034, for example, -4, a 23. What does it mean? Or 0.0, if you like. What does this mean? This is a scientific notation. By e, we mean an exponent of 10. So this is -4 times 10 raised to the 23rd power. Okay? So are we able to write this in another way, this number here? This number here can be written like 3.4 e. What should we write here in order to write this number? Which is the power of 10 we must apply here, multiply here for getting this number starting from this? We are moving this comma.
7.
I have to count. Actually, if I write 7 here, what does it mean? It means 3.4 multiplied by 10 to the 7.
Oh,
so
sorry. -7.
It's -7, right? -7 means that we have a comma here, and we move 1, 2, 3, 4, 5, 6, 7, right? It should be this 3.4 in -7. Okay, these are float numbers, and then we can use operators that are plus, minus, star for multiplying, division, and some strange operators that are this operator here and this operator here. And we can also use parentheses. Okay, so does any of you in the meanwhile is installing Python, or better, Tony? None of you?
Yes,
Yes.
I installed.
Succeeded?
I also
You are
installed it.
Tony?
Yes.
Yes.
Yeah, oh,
Yep.
good. Really. So I hope many of you are just looking at what I'm looking. So you can see this part here. Don't write here anything, but here, just use the lower part. If you cannot see this lower part, you must go to View, Shell, and check this. So if you check Shell, you can see this part. This is the interactive window. In the interactive window, you can start writing expressions like this. So for example, 3 star 7, and this is a Python expression. This is performed by converting it into what is needed for the internal, the machine language, and this is the value of this expression. Okay, try to see which is the maximum. Which is the maximum possible number? Oh, sorry, you have a very nice operator here that is a double star. That means it is the power. So 3 to the 4th is 81, okay? 3 times 3 times 3 times 3. Okay, try to check which is the largest possible number, integer number we can use here. So if I try to write 10 to the 10, this is. Oh, do you know which is the name of this number here? 10 to 100, raise it to 100 power. This number has a name.
Is it
You use this name very often during your day. This is called Google. Google comes from a tail, in which they are using this large number. This is the origin of this brand. This is 10 to the 10th. Well, but can I compute 56 raised to 100 and 1456? Yes, this is a large number. Okay, I cannot see it all here, but actually I will show you something now. Go here. I have a Python 3 interpreter here. That's the same. And if I write here what I wrote in the shell, this is the value of that number. Can you see it? But I can also add the 1 0 here. That's very large. This is a number. This is an integer number. Okay, so what we know here is integers are unlimited unless there is a limit. We have some amount of memory in our PC, so we cannot really write an infinite number. But you can use very, very, very large numbers, and that's very nice. Since you are as long as you are using integers. Well, any question? Okay. Now I put here a question. Oh, let's try to use a float number here. If I write 3.6 times 4, that's what I get. And look at this. If I write 56, I'm writing something very similar to this. 56.0. Okay, you can say 56.0 is 56. What's the difference? Raised to the 1456 power, that's what I get. It's written overflow error, result too large. Why? Here I am computing with integer numbers. Here I am computing with, this is not an integer. This is a float number. This is a real number. And it is internally represented as a real number and not as an integer number. And that's the difference. We have a maximum. Try to do this now. Which is the maximum float number? Okay, try here. If I write 2 to 1000, I get something good. If I write 2.0 to 1000, I have something different. This is 1.07 and times 10 to the 301 power. And if I try to do something more, this is too large. So it's something between this and this. And this is very close to the maximum, really very close to the maximum. Well, what do we need now? Let's look at these operators here. If I write something like some number here plus some other number, I have a number. But the difference is that if this is integer and this also is integer, I have an integer result. If this is a float and this is a float, then I get a float result. I can see a difference here. If I write 3 plus 6, I have 9. If I write 3 plus times 0, 0.0 plus 6.0, I have 9.0. We are in the integer world here, so infinite numbers, potentially infinite numbers. We are in the floating point, in the float world now, and we have a limit. Well, now I put you a question. I write this here. 2 to the 100 minus 2, sorry, the power is double star. 2 to double star 100 minus 1. Can you say me which is the result of this expression? Which is the value of this expression?
One.
Right. Well, look at this. Which is the result of this expression? 0. That's great. Why? Sorry. This goes to try here, which is 2 star 100. We say this. And what is this? Look at these two numbers. Okay, this is ending by 376. This is ending by 375. That's why when we try to compute the difference between these two numbers, we get this minus this, that is 1. Okay? Look at this. 2.0. This is, okay? And 2.0. What is this? Oh, can you imagine what this means? This is exactly as this is the initial part, and then we say that we have 301 places. We move the comma 301 places to the left. Okay? From here, sorry, to the right, from here to here. But we are only representing the initial part of this number up to there. So this is exactly the same. Can you see? We are just truncating, just cutting there, just after that 3, more or less after that 3. Well, and try to apply all these other operators. Okay, you know what parentheses is meant for. What if I write 3 times plus 4 times 2? Which is the value of this expression? I mean, I hope you all know which is the value of this expression. And I hope you all know that it's different from this. Okay? Right? Just as you did in the primary school, okay? This is a multiplication, and you do this before the addition. Is it? What about this division here? And what about this other division here? What is 10 divided by 2?
5.
Yes, it's 5. But look here, what is this 5?
It's
The float number.
Is it an integer or a float? Is it an integer number or is it a float number?
a float number.
It's a float number. That means we are representing it in this way, this is limited and so on. Look at this. What's the difference?
One gives an integer number with the remainder, I think.
Yeah, and the remainder. So if I try to compute 13 divided by 2, I have 6, not 6.5. While if I compute 13 divided by 2, I have 6.5. So this is the integer division. And what about this? This is not a percentage, nothing to do with percentage. If I have 44 cats divided by 6, we have the remainder that is 2. Okay? So this is the quotient of the division. While this is the remainder of the division. Sorry, I'm always... Okay? And what else? Okay, and then we have the double star that is the power. Okay? Well, so we are almost done with all we can do with these arithmetic operators. And we also talked about the parentheses that that are used for forcing the precedence of while evaluating an expression. So I should write this in proper order, because the higher precedence is for parentheses, then we have the power, then we have all these multiplicative operators, and then we have plus and minus that are the last one to be evaluated. So if in the same expression like this, you have all these operators here, this is the proper order. First, parentheses. And this is the most important after parentheses, then the multiplicative ones, and then the additive ones. Okay, not so much to know. What do I mean by 2 plus 3 plus 5? What is What do you think what is computed first? This or this?
The first one.
Okay, but it doesn't matter. The result is always 10. Actually, you are right. It's the first one. What about 2 minus 3 minus 5? Do we first compute this and then the result minus 5? Or do we first compute this and then 2 minus the result of this? That's different. In this case, if I write something, if I am computing this is quite different than computing this. You see that these have different values, okay? This is minus 6, and this is 0, okay? So if I do not put any parentheses, which is the meaning of this expression, this is minus 6. So additive operators and also these operators are always from left to right. If I have a chain of the same operators, or operators with the same precedence, they are taken from left to right. Okay. And now let's look at what happens on this right part here. I clear, and I write I use a new symbol now, that is this equal symbol. This equal symbol has a very strange meaning. Nothing to do with equality, nothing to do with equations, nothing to do with what we wrote here. This equal here doesn't mean this is an equality. I want that this value is equal to this value. The meaning of this equal is completely different, and this is called an assignment. Sorry for the double S. Well, what happens here? And now we have another very useful tool in Tony, that is that we can look at variables. If you do this, you see that my pocket, sorry, I was doing something else before. So just for a while, I will quit Tony. I want to clear, and I will run Tony again. If I write here my pocket equal to some number, what happens is that here at the right, I see what is called a variable. The meaning of this is compute the value on the right and store it in a variable named my pocket. My pocket is just a name. So we can choose the name of this container. And in this way, we are saying we have a box that is called the variable. And we are putting this value into this box. So Actually, there are many languages, some languages in which this assignment operator is not written by an equal sign, but we write something like my pocket and then an arrow like this. That's the real meaning. Take this value and put this into this container. But unfortunately, in Python, the language we are using now, and in many other languages, we use this equal, but it is a bit misleading. It's not the proper symbol. I do like very much this other symbol. In some other languages, you write something like this. That seems like a definition in mathematics, but this is, for example, in the Pascal language, another very old language, late 60s again. And if you remember what we wrote in COBOL, like this, compute delta as, oppure, or actually we can also write compute this and store and result in delta. That's very nice. Compute this expression and put the result in this variable. This is really what we would say in English. Okay, this is in Python. Well, so what if I say this? What's happening?
It assigns the value of 1 to A.
Okay, so we store, as we say, we memorize, we store this number into this variable. And what is I write this? The meaning is still the same. Compute this expression and store the value, memorize the value in this variable. So look at here, at what do we have in B? We have another value. We compute A plus 1, and A plus 1 means the content of A plus this number. This is the question. Why are they called variables? What does it mean, variable? What does it mean? They can vary, okay? So if I write A equal to 45, what does it happen? Up to now, the content of A is 1. But if I press enter now and I execute this, the content of A is no longer 1. Now it is 45. That's why we call them variables. They can vary. They can contain different values from one time to another. So while we are executing assignments, we can change the value of a variable. And variables are distinct. So if I say x equal to 20 and y equal to x, what does it mean? That we have 20 into this box, and now into this other box that is named y, we have, what do we have in x? In y, sorry.
X, which is 20.
I do not like this. We do not have x in y. What do we have in y? Look at right.
The value we assign to x.
The value that was in x. So we now have 20 into x and also 20 into y. What if I do this? What's happening now? I am changing the value in x, but nothing happens to y. So the real, when I am writing this, what's meant by this? If I write a variable name equal to, this is the general form of an assignment. This means compute the value of expression and store in variable name. Okay, so compute this and store here. So compute this expression, and the value of this expression is the content of x, and store in y. We are not defining any connection between x and y. Compute this, the value goes into y. After that, x is a variable, y is a variable, and they can evolve in different ways from now on. So compute and store. Well, now I would like to write a sequence of, I want to hide variables. You cannot see variables, and I try to follow in your mind what's happening now. Can you see here what is in B?
Five.
What's nice is that we have this. Yes, it's 5. Okay? Is it clear for everybody? We have 10 into A. We have 12 into B. We have, what is A plus 5? It's 15. Nothing to do with A. It's 10 plus 5, 15. And we have 15 in C. And now we have 15 minus 10, that is 5, into B. So B is no longer 12, but now B is 5. Well, and what is in A? It's 10. What is this now? What does this mean?
We increment A.
Yeah. It's I mean incrementing A. What's nice is that if I write this on a blackboard in a primary school, the only thing that somebody can say is you are wrong. A is can never be equal to A plus 1. If A is a number, A plus 1 is a different number. But it is not. This is not an equality. This means compute this value, and this value is 10 plus 1, 11, and store it into A. So if you look at right, now I would like to view a bit variables again. A is 10. Look at right. If I press enter, I compute A plus 1 and I store it into A. I want to show you a very nice feature. Okay, this is the interactive way. I want to show you some more. This is a function type that says that this value is an integer. And 3.7 is a float. 3.0 is a float, 3 is an integer. Okay? This is A. If I store another value into A was an integer, but now A is something different. A is a float now. What does it mean? That variables can contain any type of value. And we can change from time to time. So we can use the same box, the same container, and we are first storing an integer, and then we can store a float, and then we can store again an integer. And anytime we change the value of a variable, the preceding value is lost forever. If I say x is equal to 45, we know that x is 45, but if I assign 10 to x, I have no longer the 45. So an assignment replaces, destroys the preceding value. Well, okay. And using this lower window that we call the interactive windows is very useful, because we can just execute statements on the fly. We say this is the assignment statement, and this is the only statement that we can execute by now. Let's move now to the upper window. Here we can write programs. And save programs on disk. So we have an hard disk, obviously, now in our computer, and we can save these programs. So I will talk about it later, but by now, just let me put this pound sign here. Well, let's try to look at the variables here. And I write something different now. I write 8 equal to 23, base equal to 20, and now area is equal to 8 times base. Am I right? Am I right now? First of all, nothing is happening. See? We are not defining any variable here. But I can write a sequence of statements. And first of all, I can save this. And when I save this, I am just saving a file. I am saving a file. I will go to my desktop. I will create a folder. I hope you all can understand what I am doing here. Shield programs. So I create a folder here. And when I save this, I'll give a name. Let's say rectangle dot py. By this dot py here, I mean that this is a Python program. So this is a file that contains Python statements. Well, save. Nothing is happening. And after that, I can run this script. This is called a script, a set of Python statements is a script. Okay, I save, and then I can also run. By run, with this green arrow, I mean that I am asking the computer to execute all these statements. So if I press run, I see that what's happening here. Okay? But I don't see any result. So we know a lot about expressions. And look at this expression. Do you like this expression here?
Not very much.
Not very much. Why?
Brackets are missing.
Brackets are missing. The value of this expression, we know that the star is executed before the addition. So this is 2 times the value of this variable plus the base. And actually, this is not the perimeter of a rectangle. But can we say that it is wrong or not? In some sense, it is wrong. In some sense, it isn't wrong. Imagine if I wrote star divided plus 8 script written in this way. What if I try to execute this script? This time I have an error. I have an error because this expression here cannot be evaluated. This has no meaning, okay? This is a wrong expression. And in fact, when it tries to execute this line here, we have an invalid syntax. What do we mean by syntax of a language? The syntax of a language is the set of rules for writing correct sentences in that language. Well, and we are lucky because we cannot execute this line here. But if I wrote what I wrote before, this is according to the language, that's okay. As if I say, if you had to cook spaghetti, put spaghetti into water and boil them for 2 hours. That's a correct English statement. But it's the wrong way of cooking spaghetti. You cannot boil for 2 hours. Okay? So this is a syntax error. Why is it a syntax error? Because this variable doesn't exist. So I am trying to multiply 2 by what? And we have another error. This name is not defined. We don't know anything about this. This is not a variable. But in this case, this is a correct language. This is a correct statement, but this has a wrong meaning. We don't want to do this. And this is called a semantic error. And that's very bad. We are writing something that seems to be correct, but it is not what we had in mind. And these are the most dangerous errors. Because the computer says, okay, it is okay. I'm just doing what you ask. Well, so let's write this properly. And that's correct. And if we execute this would be okay. Well, we miss something. We don't see any result here. If we are writing a script, we must make informations appear on the screen in some way. And we have the first function that's meant for visualize infos on the screen. And we can write here whatever we like. An expression. So we can write here area and perimeter. So in the general case, we can use the print and we can write here whatever we like, separated by a comma. We can write commas here and write many expressions. So this is an expression. This is another expression, and whatever you like here. Okay? So the effect of this program here is first do this, then do this, then do this, then do this, and then print. And now we can see here the values in this print expression. Well, and any question? Am I too fast, too slow?
No, it's fine.
It's okay, probably too slow. So whatever. What else do we need? We need. Okay, what happens if I do this? That's a strange. What happens here?
The number becomes float. And
This is float.
Also
Okay,
the area.
what about area? Do you think area now is a float number or is it an int number?
Float.
Unfortunately, we have this. So if we perform this again, we see that we have a float area and we also have a float perimeter. So if we are using the arithmetic operators like star, plus, minus, and one sub expression is int and the other is float, the result is float. The only difference is with remember the division and the double bar division. This is always a float, this is always an int. Okay? Well, what else? Can we print something different? Print type of area. What do you expect to see now here? Type of area tells us this is a float. Okay. So what I would like to have now also is using some more features. I want to, for example, do we know how to compute square roots? Imagine we have, okay, we save this program. Now we open another program here. And what I write by this pound, this gate, this is a comment. Anything. Not only Python statements. So this is a comment, and so we can write whatever we like here. Here we compute the perimeter of a rectangle I don't know the English name of triangle rectangle. Is it rectilinear rect triangle? Okay, you know what I mean, okay? With a 90-degree angle of a triangle. Okay. So we have two variables. We can say now something more now that the name of a variable contains lowercase letters, uppercase letters, digits from 0 to 9, and this strange, the underscore sign. This is what we can use in the name of the variable, or a variable. And the other rule is that the digit cannot be the first character in the name. So cat1 is okay as a name. Cat underscore 1 is okay as a name. Cat space none is not okay as a name. So we can call this cat1, and we can call this cat2. And what about the perimeter? We will use another variable, we call it perimeter, and a perimeter is cat1 plus cat2 plus, what do we need here?
The square root.
The square root of something. How can we compute the square root of something?
SQRT.
Are we able to compute the square root? It was here, possibly. No, it's wrong. Remember that we have the double star operator. Okay? So, we want to compute the square root. We need to compute the hypotenusa's value. Okay, we can either write here an expression for computing that value. It's a bit long to write. So why don't we use another variable, hypo? And we write here how we can compute that value and store into hypo, and then we use hypo here. Well, it's easier to read. Okay, so which is the length of the hypotenusas? Are we able to compute that? Pythagoras?
Of the cat1 squared plus cat2 squared.
Okay, so we have first to compute cat1 square. Cat1 square, we can write it in two different manners, either in this way or times cat1 is okay as well, okay? Plus cat2 times cat2. Now we close the parentheses, and this all must be raised to which power?
1/2.
1/2, 0.5, that's okay. Well, and now we try to print cat1, cat2, and hypo, and also the perimeter. And it should work. We have these results. This is okay. This can be correct. 36 point something. No, yes, it should be right. Otherwise, we can also get rid of this, and obviously we cannot use it here. I can just take all these. I am doing cut and paste. and write it here. Is it correct now? What if I try to execute this program now? One step. First step, this is okay. Oh,
Yes.
okay, this step is okay. This step is okay. This step is okay. What about this?
It is not because we don't have hypo.
Hypo doesn't exist. So if I try to run this, I get an error. Typo is not defined. Okay, but I would like now to show you a nice feature of Tony. Look at this strange sign here. The bug. What we call a bug. Okay, first of all, let's get out this hypo. And now it works, okay. But what if I make something wrong here? For example, I forgot to write these two parentheses. What does it happen this way? Which is the value of this expression here now? We have an addition, another addition, a multiplication, another addition, a multiplication, and the power. Which is the first to be applied?
The power.
Yes, we are computing the square root of cat2 and then multiplied by cat2. That is a completely different, has a completely different meaning. In fact, if you see here, the perimeter is no longer 86. The perimeter is something very strange, 600 and so on. That's very strange. These are the two sides of the rectangle. This is a bit strange. Well, now we will look. This is what we call a bug. A bug you know what is a bug? A bug is a very bad insect that in ancient times where can be found in a bed, for example. And it's very nasty and very difficult to find. A bug is an error in a program, and it is usually difficult to find. It's difficult to find because it is not a syntactic error. If I write here something wrong like this is easy to find because if I try to run, okay, sorry, I must put here a comment. If I try to run this, we have this error. Cat1 is not defined. Which is the problem here? The problem is that the variable is called cat underscore 1, and this is cat1 and doesn't exist. But if we have a very bad error like this, and it's hard to find, I can use this debug feature. And I would like to show you what the debug does. Let's try to debug the program. I must save the program first. Let's call it triangle. This is the file containing the program. And now we can debug. When debugging, oh, sorry, if I zoom the screen, can you see the zoom on your screen?
Yes.
Okay, perfect. So you see these three errors here. The most interesting is the middle one, step into. So I will always press this. So I first press the debug button, and then I will press the step into. Step into means that the program is executed one step at a time. And it's very nice. This is an assignment. What does it mean? Sorry, stop, debug again, and go ahead. That's something strange. Sorry, I take it all now. Let's have a new save as triangle. Sorry, I have to close this. That something strange is happening. Save in triangle, save, replace, and debug. Okay, let's go ahead. Why doesn't it work? Sorry, that's something strange happening. So I stop Tony. I run again Tony. Okay. So I am executing one step at a time. This is an assignment. That means evaluate the expression on the right, that is 20, and store it in a variable that is cat1. And now I see that cat1 is a variable containing 20. Again, evaluate the right part that is 30 and store it in cat2. And we have this, okay? Now look at this statement. This is a more complex statement. This is an assignment that means evaluate this. What does it mean evaluating this? Starting from the left, we first evaluate this part. That means evaluate this part. That means evaluate this part. And this is 20. Then cat2 is 30. The sum is 50. Now we have cat1 times cat1. This is 20. This is 20. And this is 400. This is completely wrong because there are not the parentheses, okay? Then this is 450. Then this is 30, and this is 30 to the 0.5, that is 4 times 5 times 4, and so on. This is another number, this is another number. Okay, this is the result. And now store into perimeter. So we can follow step by step what's happening while executing any Python statement we write here. Okay? So, something more. I want to do this in a different manner. Okay, so we have to finish. Go ahead, print this and this and this, and that's the print operation. Okay, and we're done. Well, now I want to do it in a different way. I want to use more mathematical functions that we know. And in order to perform more complex operations with numbers, I have to write this statement here. This makes the package math available. And now we need to know what's inside that package. So in order to know what is inside that package, we can either go to the internet, and look at Python math, and look at here what's in Python math, and I can have help from here. But what I want to show you is that we can use the interactive part. We first import math here, and we can use the help function. You can write whatever you like, almost whatever you like here inside the help, and you have documentation about those topics. by writing help math, what happens is that we have all the functions contained in math. Okay? And this is the result. We have a lot of things here. For example, what can we do here? Take a simple one, cos. Here. Return the cosine of x in radians, obviously. Hyperbolic cosine. And this is the exponential. This is just as the power. We already have the power with double star. But what's interesting, factorial. Do you know what is the factorial function?
Yes.
And we also have square root somewhere. Logarithms. Logarithm base 10. Logarithm base 2. But what's nice is that we have the square root function. Okay? Well, so what is hypo? It is the square root. And you write this not so differently from what you write in mathematics. So by this notation, we take the square root function from the math package. So if I write import math, I can use math dot whatever is into that package. And what do we write here? We have cat1 squared plus cat2 squared. Okay? Okay, spaces are completely free. You can write spaces wherever you like. Doesn't matter. So usually this is the most common convention, to write one space aside of each operator. Use a space also here. And what else? What do we need here now? And we have to print. Okay, look at the different ways. How can we print the perimeter now? Either we can also leave blank lines, doesn't matter. Either we use another variable, perimeter equal, whatever you like, and then print perimeter. You see what you can imagine what's happening here now. Cat1 plus cat2 plus hypo, and you print perimeter, and it should work. Okay. Another way, we don't use another variable. We just take this expression here and we put it directly into the print, which is the meaning. Evaluate this expression and print the value. And it exactly works in the same way. Well, so by import math, you can do a lot of nice things. So what we are able to do now is assigning values to variables, compute expressions that can be complex, and print something. In order to do something more, we just need to know one more type. We know int type, we know the float type, and there is another important type that is str, that stands for strings. By strings, I mean sequences of variable of values of characters. And what is an int? This is an int. This is a float. This is a string. So if I use either double quotes or single quotes or triple quotes like this, I always have a string. A string is just a sequence of characters, nothing different. Okay, so what's nice is that, let's have a new command. No, sorry, let's stay here. I clear down here. If I try, I say print 45, I have 45. If I print 45, what do I have? I have 45. Which is the difference between this and this? This is an int,
Chris 20. Sorry.
and this is a string. So, by the way, if I type, I have a string. Well, and now we have a strange behavior. What do you think it happens now? I hope you're trying to do this. Run, I execute this program, and look what I have. 452. Why? Not 47.
Because it is just a text. It's not like numbers or floats or
It is the same plus sign we used here. This is a plus, but this is an addition. We are summing up two numbers. In this case, we have a string at the right and a string at the left. And this plus means just concatenate those two strings. So 2 plus 3 is 5. The string 2 plus the string 3 is the string 2, 3. This is not a number. So you see that it's very important to know which are the types of variables we are using. Because according to different types, we have a different behavior of the same operators, the same signs. Anyway, it is useful to have strings very often. So for example, here we can write many expressions. So we print this expression here, and we print another expression here that can be the perimeter is, we are printing this value and printing this value. Which is the value of this? This is just a string made by these characters. And this is a more complex expression. This is the value we obtain by applying this operator to these values here that are integers. These are integers. This is not an integer because square root. What about square root? Which is the result of this square root function? Is it a float or is it an int?
Float.
Maybe float, but if I try to compute math.sqrt of 100, is it a float or is it an int?
Int.
Actually, I had to import math first. And then by the upper arrow, This is a float. So the square root function always compute a float value, even if it could be an integer, but it is always float. And we know what it means. We are now dealing with floats, and so what about this? Is this a float or is this an int?
Float.
Why is it a float?
Because
Can you
height
imagine
is float.
how is this expression evaluated, computed? We compute. We first add this and this. So what is this? Int or float?
Integer.
This is integer. And this?
Also integer. And
This is
get
integer.
one.
And so this is integer as well.
This is integer also, but when we with hypo,
Yeah.
it's one integer and one float, and it combined
The
will
result
be a
is
float.
perf. In fact, if I write here 3 plus 1.4, we have a float. But even if it was 1.0, it is a float. So up to here, it is still is an integer. And then for summing up with a float, this becomes float and the result is float. And this is a float. Okay. Obviously, if it were 20.0, it would be different. Well, so by import math, you can do a lot of things. By the help, you can do whatever you do. You by help math, you see a lot of information about the math functions, and you can try to write programs to do something. Actually, I only want to show one more. Actually, let's stop for a while. Do you have any question now? We can make calculations. We can use as many variables as we like if we need. We can print. By print, I mean that he has some output. But imagine that we want to, here we want to take a value from the keyboard. And also here we want to take a value from the keyboard. And then from these two values, I want to make all my calculations and give the perimeter. That's what we still miss. And we have the input function. And this takes, or as we usually say, reads a value from the keyboard. And we can do the same here. I am using Command C and Command V, so cut and paste, and this reads a value from the keyboard. What's interesting is that I can write here a message, a string, write the first side, and then here I can say write second side. Okay, or better, first edge and second edge of this triangle. The third will be computed because we know we say this is of a 90 degrees triangle. Oh, look at what I'm writing down here. I am taking all these and copying again here. That's a bit bad. That's bad. And let's do something simpler. This is edge 1, this is edge 2, and this is edge 3. And we do the same here. It just is a triangle now. And we do this again. And we say the perimeter is, what can we write here? I write perim and then I compute perim here. What do I write here? Well, try to run this. We save again. We are saving always in the same file. If I try to run this, that's what I see. The input function just shows this message, this string here. We can write something here, 23, press enter, and this is put into variable edge 1. Now the second edge is 10. This is not very nice. We can do something nicer here. How can we do something nicer here? Just put a space, a colon, or something like that, but we will do it later. The second in 10, and the third one is 20, and that's what we see now. What's happening? What's the error here? Can you explain this behavior? What's happening here?
Their string.
Strings. Yes. When I use the input function, the result of this function is what I wrote here, but not as a number, but as a string. And when we are using this operator, we have a string here, a string here, a string here, and we are just concatenating the string 23, 10, 20, and we have this string here as a result. So what should we do? What's the error? Edge 1 is a string. I want a number. Well, look here. If I write here int, what is this? This is a string. This is a function. We use the same syntax as when you apply a function in mathematics with these parentheses. The result is, this is a number. This is an integer number. And look here, if I write float of a string, what do I get? Is the float value represented in this string. This is a kind of conversion. Take a string and derive the float value that corresponds to this. Take a string and derive the int values that corresponds to this. So what do we need here? First of all, it's very nice to add something to this message, just to separate what I see here. So I will print a triangle, colon, and space, and that's only a bit nicer. But what should I do here now? Try to debug. Go ahead, go ahead. This is a message, input, I write 23, enter. This is a string 23, you see, and what's in edge is the string, not the integer 23. What should I do now? So stop, we are wrong. What should I do with edge 1? Edge 1 contains the string 2, 3, not the integer or the float 23. can I compute something else and put it into edge 1 again? What happens in this way? Take this value, apply this function, and put the results into edge 1. What does it mean? Take edge 1, compute the corresponding float, and store into the same variable. If you remember, it's as if I write something like this, not so different. I use this value, compute another value, and store into the same variable. Okay? Take this value, compute this function, and store the result here in the same variable. So I do the same for the second one. So I read from the keyboard, I get a string, and this string is now transformed into a float. The same with this other variable, and the same with the third one. Okay? And now, save the file. I write 23, I write 10, I write 20, and the result is 53. I would like to show you step by step. This is the message. This is the input. Execute the input function. I write 23 and press enter. Look now what's happening. The result is 23, and this is stored into edge 1. Look at edge 1. Now you have the string 23, not the number. Then I take this value, apply the float function. What is the result? The result is 23.0. And where do I store this value? Into the same variable. So now the edge 1 variable should contain a float number. Okay? Is it clear?
Yes.
So the effect is now is that edge 1 is a float number. This is the number I wrote here. Well, if we do the same with the other one, 20, we first have a float, sorry, a string, and then it is converted to float. And the same with the third one. Convert and store. And now I am evaluating in line 9, I'm evaluating 23 plus 20, and the sum now is 43, plus 10, and the sum is 53, and this is what I get into perimeter. And now I print this value, and this is what I see on the screen. Okay? Well, I can also do it in a single step. Stop here. I can do it in a single step, just to look at it better. I can also say, well, apply this function, and then to this value, apply the float function. It is as if you apply a function to a function in the mathematical language. You can write in mathematics sine of cosine of x plus 1. This is not a not a strange expression, okay? And here we are just saying we compute this function on this value. The function means the result is what we get from the keyboard as a string, and then to that value we apply the conversion to float. Okay? This is exactly equivalent to writing this in this other way. Blank lines are okay. Oh well. Sorry, I forgot to say a very trivial problem in Python, that if you write all your statements in this way, you must respect this alignment. So if you try to write something that is starting at column 3 instead of column 0, like in this way, you get an error. If I try to execute this, I have, look at here, an indentation error. Indentation means how we align statements. Unexpected indent in line 5. Because here you were starting in column 0, or sorry, 1, and here we are starting to the right, and you cannot do it. You must start this. You could do something like this. That's okay, but it must be all in the same column. So you will never do this by now. Sorry. This is okay. This is correct. No, sorry, you cannot do it because you cannot do in this way. So you must take all these and edit, indent, dedent. So go back to the left. You must follow the same alignment. Okay, we cannot do so much by now, but we know how to write expressions, how to use the math functions. Actually, we don't need the math functions here because we don't have the square root, but we can import as well. So this is not needed now. We can make assignment, and we can either print values or get values from the keyboard. And I think it is enough for our first 2 hours. So you can try using Tony. You can try writing programs in which you read what you like from keyboard. Be careful. Convert to int or to float because you are reading only strings. Then compute whatever you like and then print results. So what I suggest you is try to apply these operators, this operator, this operator to values that you read from the keyboard. And then if you like, you can try playing with this with the interpreter here and test whatever you need. If you are going to write something here and you want to check which is the behavior, use the interactive part. For example, while we were writing this, if I want to be sure of what float means and if I can convert, I can use this. I have the int, I take a number here, convert to int, and I get this. What does it happen if I'm typing in a string a float and trying to convert to an int? What does it happen here? That's okay. Or not. I can check in very fast here. Another question, for example. What if I try to convert an integer value to a float. Is it correct? Which is the result? Is the float value corresponding to that integer value? What if I do the opposite? What does it happen here?
Convert to 5.
Or to 6? To 5 or to 6? That's the question. To 6, to 5. So it's always truncated. Well, the question is there, how can I round to the closest integer?
With a function.
Okay, look into math. There can be possibly some function there, and you have to find it or try on the internet. But there is another possibility. I will have an error now, obviously. I am writing something that this is not Python, okay? But what if I imagine we have a variable. What if I convert to int? This is cut. I just cut the decimal part. But what if I say think about this. Choose something so that we round.
0.5.
Try with 0.5. We want to be sure that if I write 5.5, we must go to 6. And if I write 5.49, I want to go to 5. And obviously, 5.7 must go to 6. So yes, this is right. This is 0.5. So we don't need to look at math. If I want to convert to an integer, rounding, I just convert. But before converting, I take my value, I add 0.5, and then the result is transformed into an integer. And this is a proper rounding function to the closest integer. That's okay. Always, okay, so I think it's enough. But now we will meet in 2 weeks, so you have a lot of time you don't have too much to experiment in Python, but try to read values and compute and print whatever you like. We cannot do much more by now. Okay. For any question, I want to leave you my address. If you have questions, you cannot succeed in something, you can write to Paolo Franciosa. Okay, I give you my personal address. But if you write here, first write that you are a student of this school, first of all, and then precise questions. Precise question means I want to do this, I am writing this program, and it doesn't work. And but you must send me the program, otherwise I cannot answer you. Okay? Well, so thanks for staying here for 2 hours, and see you in 2 weeks.
Thank you. Bye.
Bye.
Thank
Bye-bye.
you.
Bye.
Goodbye.
Bye.
Bye.
Thank you. Bye bye.
Goodbye.
Goodbye. Oh, stop here. Okay, so Alex is still there?